Hi guys, we're back here doing Eureka Math again. We're on lesson 4, unit 4, and today we're going to do a quick review of what we talked about on Tuesday, and now we're going to move forward into other things to learn. So, today's lesson we are going to be specifically talking about identifying and defining and drawing parallel lines. The first thing we're going to do is a little review of what we talked about on Tuesday, which was talking about perpendicular lines. To do that, we're going to do a little exercise here, and we're going to talk about what we see in these letters that make up the word real. So we have the R-E-A-L, they're all capital. If we were in class right now, I'd be asking you, so which one does any of these have obtuse lines in them, or angles? Does anybody see an obtuse angle anywhere? And I would say, no. I don't see any obtuse angles in any of these, unless you want to count maybe the straight angle that's going down here, but that's a stretch. Let's take a look at, how about acute angles? Do we see any acute angles in here? Okay. If you said maybe the A, and if I would have formed it more like a point, that probably would make you think of it. If you look at this A, okay, we know that almost if we took it out individually, it would look like this. Okay, so that's actually like an acute angle, less than 90 degrees. Can we see any right angles or perpendicular lines? Definitely. All right, which two letters do you see perpendicular lines? Shout it out. Okay, if you're thinking the L, yes, the L you can see right away has a right angle. Those are perpendicular lines. And then what's the other letter that you're thinking? I know I'm thinking the E. And you can see right away that the E has several right angles. A lot of them. Okay, so you can look right here. Pretty much through the entire capital E. Does the R have any perpendicular angles or lines? You don't see any right angles in that, so definitely nothing there. And the A, of course, we know is already an acute angle, so there couldn't be any perpendicular lines there either. Okay, so that's an example of using capital letters to incorporate obtuse, acute, and perpendicular lines all in one. Pretty neat, right? So now we're going to move on, and like I said, our focus today is talking about parallel lines. Okay, I know that you've heard me talk about parallel lines in class before. Hopefully you remember what they are, but if you don't, that's okay, just listen. Okay, I'm going to tell you the definition right now of what parallel lines are. Parallel lines are two lines that never touch, no matter how far you extend them. Okay, so let's take a look at my trusty board here. And I'm going to show you what I mean. So first of all, how many lines did I say that parallel lines have to be? Could it just be one line like this? Nope, you have to have two lines. So if I draw two lines, okay, here's one line, and I have my second line that I'm drawing. Okay, so you can see that they're lines, they're exactly across from each other, and we know that lines go on forever and ever. Okay, but even if we extend these lines, they won't touch, will they? Okay, so that's the main thing with parallel lines. They will never touch. I'm going to show you an example of, sometimes people think this is parallel lines, but it's not. Let's see here. So look at these two lines that I just drew. Put the other ones away. Okay, what do you think of those two lines that I just drew? Are those parallel? Are they exactly the same distance apart? No. Do you see how this one's a little crooked? Okay, so if we know that lines go on forever and ever. If I extend this line, let me try to do this, going up here, and eventually, look how far I can go. I can keep going off. I can go off the paper. It keeps on going. And then let's look at that other line. If I extend those lines, what happens? Do you see what happens there? I know it's a little glary. So they actually end up intersecting each other. We cannot have that in parallel lines. Parallel lines strictly have to stay the same distance apart at all times, just like this. They can never cross because that's not parallel lines. Okay, so if you could remember that rule, you'll always know what parallel lines are. Okay, so I'm going to give you some examples. I want you guys to be able to tell which ones are parallel lines and which cannot be parallel lines. Let's take a look at our part right here. So let's look at this first group, this one right here. What do you think? Are those parallel lines? I believe those are. And of course we should be using a ruler to make our lines extra close together or extra straight. And we could actually measure them to make sure they're exactly the same distance apart. Okay, let's take a look at our next group. And remember, these are diagonal. They're still parallel lines. They could be diagonal. What about here? The middle one? Are those parallel lines? Yes, they are. Okay, they're straight and they're going in one direction and they are not ever going to touch each other. What about this one? This one's on a diagonal going down. Do you think that those are parallel lines? Well, I believe that they are. They look good to me. Let's look at our last one here. Does that look like parallel lines? No, I can tell right now that if I extend those lines, you can do that with parallel lines. Look what happens. I'm going to show you. They end up intersecting, and that is not parallel lines, so we could cross that one out. There we go. So those are all examples, but this one on the bottom, nope, it ends up intersecting, and that means that it's not parallel lines. All right, the last little thing I want to talk to you about is shapes. Can shapes have parallel lines? What do you guys think? Shout it out. Yes? No? Maybe? I think so. Definitely. Okay, there are certain shapes that have parallel lines, and there's certain shapes that absolutely do not have parallel lines. Let's take a look at our first shape. Hopefully you're thinking in your head, oh, it's a rectangle. Yes, rectangles definitely have parallel lines. Okay, so if I was labeling this, I would say that line AB is parallel to line segment actually, DC. Okay, because you can see that this line is parallel to this line. But then it actually rectangles have two sets of parallel lines. From AD to BC, okay, this line is parallel to this line over here. Okay, so rectangles have two sets of parallel lines. Let's look at squares. Squares are very similar, but they have all equal sides. So yes, they have two sets of parallel lines. You can see AB is parallel to CD, and then AC is parallel to BD. Got it? Let's take a look at this next shape. Anybody remember what this is called? I know we've talked about that one. This is called a trapezoid. And how many sets of parallel lines, or does it have any parallel lines? What do you think, guys? This is going to be a question on your exit ticket. So, yes, trapezoids have one set of parallel lines. You can see here, we have CD is parallel to AB. Now, if we said AC and BD are parallel, that would be false, because they are not. But if you looked at these lines, even though they're not the same size, they are exactly the same distance apart, and they will never interfere or intersect with each other. Let's take a look at triangles. Can triangles ever have parallel lines? What do you think? Triangles. Any kind of triangle. I'm gonna make I'll make a right triangle for you. Does it have parallel lines? Two lines that are equal distance apart but never touch? I hope you said no. Triangles can never, ever have parallel lines because there's only 3 lines there to begin with. And let's take a look at our famous circle. Does our circle have any parallel lines? No. We could have parallel lines go through it, like this. But the shape itself is never, ever have parallel lines. The last thing I wanted to show you is just a regular shape, or symbol, I should say. Let's take a look. All you music kids out there, we have musical notes. What do you guys think? Any of those lines parallel? Of course, I'm not completely even with what I was doing, but what I was trying to show you is our musical notes. The thicker lines there. Okay, this line going down is parallel to this line going down. This line on the side here does not have any parallel lines because there's nothing below it, right? Or above it that's parallel. But this line can be parallel with this line. Okay. Like I said, we have shapes that have parallel lines. We could take a look at we know that triangles don't have any parallel lines, and we know that circles and triangles will never have parallel lines. All right, so I want you guys to just recap on our definition, and then you guys are going to watch a short video, and then you're going to do our exit ticket. So let's remember that parallel lines are 2 lines that never ever touch each other, no matter how much or how far you extend them. So for last example, if I have 2 little lines here, I could extend those lines because we know lines go on forever and ever. And look here, are they ever going to touch each other? No. Okay, so please keep that in mind while you're doing your work. And if you need to, watch this video again, and I'm sure you'll do fine. I'll talk to you guys soon. Have fun. Bye.